Alright, here we go. We're going to talk about renewable energy, Section 3, Chapter 7. Alright, your first one, your objectives today. Explain how let's try that again. Explain how geothermal energy may be used as a substitute for fossil fuels. Compare passive and active methods of harnessing energy from the sun. Explain how water and wind can be harnessed to generate electricity. There's a typo in there. But anyway, electricity, that's spelled all wrong. Geothermal energy. Okay, again, let me actually, I'll see what I can do about this, and maybe I can insert a video here to show you how energy is formed. But basically, you have a power plant. The power plant generates electricity either through some heat source that boils water. The water turns to steam. The steam turns a turbine. The turbine turns a generator, which forms electricity. So that's how that works, and that's important to understand because what we're going to do is talk about different ways to generate that steam. A renewable resource is a natural resource that can be replaced at the same rate at which a resource is consumed. So basically you say if it can be replaced in our lifetime, it's a renewable resource. Geothermal energy is energy produced by the earth. So the magma in the earth helps produce that geothermal energy. It can be replaced in our lifetime, basically. So that means that it's a wonderful energy source. Resulting steam from the water passed by nearby magma or hot gases related by steam deep in the earth produces a large amount of geothermal energy. So we put that water down there, this water turns to steam, we pump the steam back up, it turns our turbines, we get electricity without using any heat source to boil that water. We've harnessed that by drilling wells to reach that hot water. The steam and hot water use as a source of heat, source of power to drive turbines, which generate electricity, which is what I've explained a couple times already. Solar energy. This is energy received by Earth from the sun in the form of radiation. Solar energy can be converted to heat in many ways. If you talk about a passive system, it means sunlight enters the house, warms the building, stores heat for the evening, okay? So that's like when you're sitting in your car and the sun's shining through the car window. That's passive. You're not doing anything to collect that sun, but the energy is coming into the car and heating up your car, or heating up a building, or if you have the windows open, heating up through the window. That's passive system. An active system, on the other hand, uses some type of cell to collect that heat and then convert it to electricity. So that means you actually have a process that collects that heat and collects that energy. Like the top of your calculator. Top of your calculator, that little window right there, that's an active system to collect solar energy and run the solar cells to convert that to electricity to run the calculator. Hydroelectric. Again, this is another way. It's the same idea. You're turning a turbine to generate electricity through a generator. In this case, we don't need steam. We have running water that does that. Or we can do it from the oceans and the tides. With the tides, the waves wash in. They're collected behind a wall. The wall opens up, allows that water to come back out. As it does, it turns the turbine. As it comes back out, just like a water wheel would, and we collect that energy. Then the next day, the tide comes in again, and we do it again. So, very easy system. 11% of all the electricity in the United States comes from some type of hydroelectric power plant, including the electricity to run this house here. Comes from a hydropower plant that's in Marshall here. So you get dams that hold the water, channel the water through the plant turns the turbine, which generates electricity. You're noticing a pattern, I assume. I hope, anyway. It's kind of blurry. There it goes. Okay, we talked about biomass before. Biomass is anything that is organic, and we've talked about that a couple times. You get an organic system that uses, there's something on the screen there, uses either energy from the plants or animals that the plants that we talked about. We can talk about things like sugar cane. I'm sorry, that picture's really bad. Anyway, okay, hold on one second. I'll see if I can fix it. I don't remember how to pause. Well, anyway, I'll leave it there for now, and then we'll go from there. Sorry. So sugarcane. These are the things we talked about in class. So you can have those stalks of those plants that we normally just destroy. We can turn it into a biomass fuel source. We can also use manure, which we can either collect the methane off, which we can burn, or we can actually get the liquid fuel, such as ethanol, that comes from bacteria and from corn plants. So all the things we talked about in class before. More than half all the trees that are cut down are used for fuel for heating or cooking. So all those trees we use for lumber, or if you heat your house with wood, that's exactly what we're talking about. That's a biomass. Name 3 sources of renewable energy. And right now I'd like you to pause your video and write those down. Some of you are not writing them down. Please make sure you do. Alright. Answers may vary, but here are some of them: geothermal, solar, hydroelectric, biomass, things we just talked about in the last few slides. Energy from wind. Wind energy is now being used to produce electricity in locations that have constant wind. You see wind farms that have hundreds of giant windmill turbines. They produce enough energy to meet the electrical demands of an entire community. You're seeing that in northern Michigan. I think you're going to see it more and more as these wind farms pop up, because they're a cheap way, well, I shouldn't say cheap, they're a way to generate electricity without the pollution. They're not practical everywhere because we don't always have the wind blowing. Wind energy cannot be depended on, so some places it's just not going to work. Okay, here's a dam of how this works. So you have hydroelectric, you have the dam that blocks up the water, you open a little pathway there, it's called the penstock. The penstock turns the turbine, which turns the generator, which is above it, and the generator generates the electricity, and then the rest of it goes off the spillway or discharge pipe. Here's a close-up of it on the right. Water supply flows down the penstock from the reservoir through the turbine, which spins the wheel turns the generator. Pretty straightforward design. Let's see if this will play. They never play on mine. Remind me in class to play all these, because this is the title one and I do want to show you this one. So this is one we'll have to do. I don't know why it doesn't play on mine. It plays at school, but not here. Alright, thank you very much. We'll look for section 4.